G'day everyone, how you going? This is a Year 8 video, Year 8 Algebra. I don't normally do videos for Year 8s and lower school. It's normally my upper school stuff, but I thought we've got a test coming up on Tuesday. I thought I'll do a video of all the things that we need to know. Over here I've got a list of the stuff that I've got to do. It's going to be a long video. I apologise. I'm going to leave this part of the video the same. This part over here will be the section that I'm working on, so just skip on through the video. When this changes, we're on to the next section. Here we go. So, Year 8 Algebra. Let's get back to a few basics first. Let's tidy up a few basics. If we are talking about an expression, there's no equal sign. It's just a collection of terms. I'll get to that in a minute. So an expression is just a collection of terms. Whereas an equation has an equal sign. That's where the word comes from. Equal sign, equation. It's balancing this side with this side. Alright, the two sides are balanced a bit like a seesaw. I often do this one and say see it as a seesaw that is balanced. Put more people on one side, I've got to put more people on the other side. Keep it balanced. Now, diving into these things and these as well, let's talk about the words we should be using. So the first one is this one here. Now that is a coefficient. A coefficient is the number that is out the front. If you like, it's how many times we are multiplying that thing by, the coefficient. Then we have these, the letters. They are pronumerals or variables. The language there is either is good, so pronumeral I'll use for now. And pronumeral means that it's a letter standing in the place for a number. We don't know what x and y is equal to at the moment, so that's the best we can do. This last one here is a constant. There's no x's or y's, there's no pronumeral or variable with it, so we call this a constant. Now regardless what x or y equal, this is always 6, never changes. Whereas these ones change depending upon what y is equal to. Right, that's some basics there. Let's get on to the first topic, like terms. Like terms have to be exactly the same in the variable or the pronumeral. The number out front, the coefficient can be different, but the letters have to be the same. So 3 examples I've got for us here. 6m, 2n, 3m, 2mn. This one and this one are like terms. And they're like terms because they have the same pronumerals to them. Have a look at this next one. Scan through them, see if you can pick anything the same. I think that this one and this one are like terms because they have the same pronumerals. Now that brings me into another concept here that I need to brush up on. This is AB. There's no coefficient out front. That's okay. We're a little lazy as mathematicians. So if we don't need to write something, we don't. This one here is really saying one lot of AB. But there's no need to write that, so we generally don't. If you write the one at the moment, not a problem. Okay? But try and get in the habit of recognizing that this means one lot of AB. I used the example in class. I said to my group of students, I said, if I said go off into the library and get a book, you know to come back with one book because the word a is singular. If I said go and get a few books or several books or many books, you would know to get more than one. So the English language has the same as well. Here we go, last one. Now, a little trickier, we've got some squares going on there. 4x squared y, 2xy squared, 3xy, and minus 6xy squared. I think that one and that one are going to be the like terms. Don't worry that it's a minus 6 out front. For a similar reason here, I didn't worry that this was a 1 and that was a 4. I'm only looking at this part of it. Now, one other thing we need to tidy up there or make ourselves aware of is that when I write terms like this, it's really, there's a multiplier, there's a little multiplier in here. Now we don't write it because the x's and the multiplier, they get confusing. So in algebra, we don't write a multiply sign. We just put them next to each other and we know that means multiply. Sometimes you will see a dot on the line to mean multiply. That's okay. But then we've got to be aware if that was a decimal place, like 10.5, then the decimal place would be put in the middle of the line. So we've got to be particular on what we're doing. Just see the fact that if we write things next to each other, they mean multiply. Right, I'm going to tidy off. Here we go. Let's get on to the next thing. The next thing I've got over there is to add and subtract terms. Add and subtract terms. Now, this is easy, I think. I think it's easy. You will after this as well. If we had something like 4a plus 2b plus 3a plus 2c. Now, whenever we're adding and subtracting, we can only add and subtract like terms. So we first look through here and we say, well, this and this are like terms. So I can put them together. 4 lots of A and 3 lots of A is going to give me 7 lots of A. I can't do anything with this, so just write it down as it is. I can't do anything with this. That's it, I'm done. That's all I can do. Here we go, another example. 2x plus 4y minus 2y minus y minus 2x. Okay, lots of x's and y's going through. Let's look at the like terms. X. If I've got 2 of something, 2x, and I take away 2x, I've got nothing left. I really have 0x. But we don't need to write that. If you have 0, I don't know, camels, you don't run around telling everyone you have 0 camels, you just don't tell them. So we don't actually need to write this. 4y minus 2y, well that's down to 2y, minus another 1y will just bring me down to 1y. Or this whole thing here, we don't need to write this, and we don't need to write the 1. This really is just y. That's what it simplifies down to. Adding and subtracting like terms. Lots of examples in the book for you to do as well. On to the next one. Here we go. Right. Multiplying and dividing. Let's do multiplying first, okay? So this is multiplying. Right. So if we have 4x times 2y. Now, the rule is simple here. Here's the rule. Multiply the numbers, place the letters. That's all you need to know. Multiply the numbers. 4 times 2 is 8. Place the letters, x, y. Done. Multiply the numbers, place the letters. Let's do another example. 4xy times 3xyt. Make it harder. Doesn't matter. Follow the rule. Multiply the numbers. 4 times 3 is 12. Place the letters. Now watch. xy, xyt. Now, we're not quite done because we can tidy up here. Rather than writing x and x, we write x squared. Instead of writing y and y, we write y squared. So this becomes 12 x squared y squared t. Multiply the letters, multiply the numbers, place the letters, tidy up. Easy. Lots of examples in the book on that one too. Rightio, let's go on to divide. You can replay these anytime you like. Let's go on to divide. What do we got? There we go. Right, let's say we've got 4xy divided by 2y. Now, this is an easy one to start with because you look at the top line, you see what you got, you look at the bottom line, anything that is on both of them, you cancel out. So, y is here, cancel them out, gone. Don't need them. Then we've also got to see that this 4 is really 2 times 2. So instead of writing 4, I could have 2 times 2, and then I can cancel one of those 2's. Now what am I left with? On the top line, 2x. Now, you might think, oh, I've got 0 left on the bottom line. No, no, no. You don't have 0, you have 1 left on the bottom line. Because y went into that once, and into there once. 2 went into there once, and into there once. So you've still got a 1 on the bottom line. But then we can recognise that if we have 2x divided by 1, that's just equal to 2x. Think about 5 divided by 1, 5. 7 divided by 1, 7. Minus 3 divided by 1, minus 3. 2x divided by 1, 2x. Well, let's do another example. 14 x squared y z cubed over, let's go with 10 x y. There we go. Have a look at that one. Look at the numbers. What will divide into both? 2 will divide into both. Goes in here 7 times. Goes in here 5 times. Remember, x squared means x times x. So, what I can see this as is x times x. So this x will cancel with one of these. I've got a y top and a y bottom, so they will cancel. I've got no z's on the bottom line, so I can't do anything with those z's on the top line. What do we got left? 7x z cubed over 5. Done. That's it. Cancel top line, cancel bottom, done. That's divided. Right, let's get on to the last 2 steps. The last 2 steps are expanding brackets and then factorizing. One's the reverse of the other. So let's do expanding. Now, let's have 2 out front of 4t plus 4. Alright, let me tidy that up. There we go. Now, or even better, I'm going to change that to a different letter. It's too close to a 4. S plus 4. Now, usually with BIMDAS, I'd say work inside your brackets first and then do the multiply. But with algebra, we can't do anything with s plus 4. I don't know what s is. We can't do anything with s plus 4. So this is what we do. We multiply the 2 into the bracket. We multiply 2 by every part of the bracket. So therefore my question really becomes, oh, I need more hands to hold pens. The question really becomes 2 times s plus 2 times 4. Remember, this means multiply. If it was up here, it would be 2.4. 2 times s, I can just write that as 2s. 2 times 4 is 8. There we go. We've expanded the brackets out. We've expanded them out. Let me do another question here, then I'm going to do my factorization stuff over here. So, next question is going to be, oh, get another pen, here we go. Let's go 4t out front of s plus 5r. Throw in a couple other things in there. Same story though, same story. It's 4t times s, and then 4t times 5r. Now this is where your multiplication idea you've got to be good with. 4t times s is actually going to be 4, and I'm going to write it as st, because we usually write them in alphabetical order. Then 4 times 5 is going to give me 20. Remember, multiply the numbers, place the letters. T and R, I'm going to put them in alphabetical order. RT. Bingo. There we go. That's the expanded version from here. Now, factorization. This it gets a bit tricky, but this is our last one we've got to do. When we're factorising, and as I say, you're going to, let me get the word up, we're going to use this right here as my question. Now it was the answer here, but I'm going to use it as my question. 2s plus 8. Now when you're factorising, you are looking for something that is common to both terms. And I see 2 here, and I know 2 will divide into 8. So I say, well, I'll put 2 out front. Brackets. I've got to put stuff in here so that if I was to expand it, I would get back to that. Now my answer is going to be s, because 2 times s will get me 2s, and plus 4, because 2 times 4 will get me back to 8. Now notice this. My question here became my answer there, and my answer there is my question there. That's what I mean that one process is the reverse of the other. Expanding out, we're getting rid of the brackets. Factorising, we're trying to put it into brackets or into its factors. Factors meaning 2 things that multiply together to give the answer. Now let's do this one, and I'm going to purposely stand in the way of the answer here a little bit. It's 4st plus 20RT. Now to do this one, I would say, okay, well, where is my things that are common? What's common in both of these terms? Well, I see a 4 here. This pen's not playing the game. I see a 4 here, and I know that 20 is 4 multiplied by 5. So I can see a common factor of 4 that I can bring out front. I have a t here and a t here, so I can bring that out front. 4t brackets. What have I got to multiply 4t by to get 4st? It would be s. What have I got to multiply 4t by to get here? Well, I've already got the 4 and I've got the t. So I only need 5r. And then hopefully, look, here's the question. That became my answer. Here's the answer. That was the question. So factorising and expanding are the reverse processes. All right, if you can understand one, you can do the other. Hopefully this has helped you guys. This is everything pretty much I think you need in the test. Obviously 3.1 to 3.7 is the section I want you to do. Lots of questions to practice on. Practice is the big thing here. I hope this has helped, guys. Good luck for Tuesday.